Bismillah ar-Rahman ar-Rahim. Come back to this topic, the Laminar Rule part 3. In the last two parts, we spoke about the form 0 over 0, the indeterminate form 0 over 0, and infinity over infinity. In this part, we are going to speak about the infinity minus infinity and 0 multiplied by infinity. Just to remind you about the Laminar Rule, we said that the limit of the function f of x divided by g of x as x goes to a is equal to the limit of the derivative. Provided that the functions f and g are differentiable at or on open interval containing x equal to a, and the limit of the derivative f prime divided by g prime exists. Now let's speak about these two forms, now infinity minus infinity and 0 multiplied by infinity. Number one, find the limit of one over len of x minus 1 over minus 1 as x goes to 1 plus. I need to find the limit of this function. We know that the limit of, len of 1 equal to 0. So 1 over 0 is equal to plus infinity and minus 1 over x minus 1. When x goes to 1 plus, I will have also 1 over 0 plus, which is infinity. So this is infinity minus infinity. This is of the form infinity minus infinity. So it is indeterminate form. We don't know what is the limit in this case. Is it 0? We are not sure. So we need to simplify this function. If I want to apply the Laminar rule, we have to write it in this form as a fractional function. F of x divided by g of x. And then I need to check, is it 0 over 0 or infinity over infinity? Because we know that the Laminar rule can be applied if it is 0 over 0 or infinity over infinity. Then we can apply the Laminar rule. Now let's see this function. Can you write it in a rational function so that it is 0 over 0 or infinity or not? I have difference between two fractions. Let's combine these two. Then check. Now this is equal to the limit of, I will have x minus 1 multiplied by len of x divided by x minus 1 minus len x as x goes to 1 plus. Now if we replace x by 1, I will get 0 over 0. So we got the first form now, 0 over 0. And the functions are differentiable at x equal to 1 or around that number. X minus 1 and len of x. So the conditions for Laminar rule are satisfied. So let's apply the Laminar rule. I will have limit. Now the derivative of the numerator, I will have 1 minus derivative of len of x is 1 over x divided by, this is a product rule, derivative of the first one, this one will give me 1. So it is 1 multiplied by len of x plus 1 over x multiplied by x minus 1 as x goes to 1 plus. Now if we replace x by 1, in the numerator I will get 0. In the denominator also I will get 0. Can you see it is 0 over 0, which means we can apply the Laminar rule for the second time. Again, applying the Laminar rule, this will equal to limit derivative of the numerator. I will have 1 over x squared. Because derivative of 1 will give me 0. Minus 1 over x will give me 1 over x squared. Down. Derivative of ln of x will be 1 over x plus. See, let's take this one. 1 over x multiplied by x minus 1 can be written as 1 minus 1 over x. Which is 1 minus 1 over x. So the derivative for this one, this part, will be 1 over x squared. I just open the bracket, 1 over x multiplied by x equal to 1, and 1 over x multiplied by minus 1 equal to minus 1 over x. That's what I did. I opened the bracket and differentiate, I will get 1 over x squared. As x goes to 1 plus. Now if we substitute x by 1, we have 1 in the numerator and 2 in the denominator, which is equal to 1 over 2. So the limit of this function is 1 over 2. Take another one. Number 2. Limit 1 over x squared minus 1 over x squared multiplied by secant to x. And this goes to 0. Now you can see the first one, 1 over 0 is equal to infinity, and second one also infinity. So I will have infinity minus infinity. And we need to apply the Laminar rule, which means I have to write it as a rational function or a fractional function, as a fraction. Numerator divided by denominator. So I'm going to combine the two parts. Is limit the common denominator is x squared multiplied by secant of 2x. That is just we multiply the first one by secant x. So I'll have secant 2x. The numerator minus the second part, we did nothing with that one. Because I have in the denominator x squared multiplied by secant 2x. So we didn't do anything for the second part. Only the first part we multiplied by secant of 2x. And we need to find the limit as x goes to 0. Now, if we replace x by 0, we will have the form 0 over 0. So it is 0 over 0, which is the condition for the Laminar rule. We can find the derivative of the numerator and the denominator. So this is equal to limit derivative of secant 2x will be 2 multiplied by tangent x multiplied by secant 2x. And the derivative of the denominator, we will apply the product rule. It is 2x multiplied by 2x plus the derivative of secant 2x will be 2 tangent 2x multiplied by secant 2x multiplied by x squared. If we replace x by 0, it is 0 over 0. Again, I will get 0 over 0. It means I have to apply the Laminar rule again for the second time. Or we might think about simplifying the function, because this is a very complicated one. If we simplify this function, tangent 2x multiplied by secant 2x, up and down, if we can do it, that will be great. We know that tangent, let me take it aside. Can be written as sine 2x divided by cosine 2x multiplied by secant, which is 1 over sine 2x. Can we simplify this one? No, it is not. We can't do it. What about the denominator? It will be the same thing. 2x multiplied by secant 2x plus 2 will be the same sine 2x divided by sine 2x squared. If you multiply these two together. So you can see, still it is not clear how to simplify it. Let's try. For the numerator, I'm going to write it as sine over cosine squared. I can differentiate to applying the product rule, but this will be complicated a little bit. So this is equal to the limit of the numerator is 2 multiplied by sine x divided by cosine squared 2x. This is the numerator. And the denominator will be 2x divided by cosine x plus 2x squared multiplied by sine 2x divided by tangent with secant will be down cosine squared. As x goes to 0. Now I can bring this down, multiplied by cosine square up and down. Speak about the denominator, cosine square. So it will be limit. If you multiply cosine square up and down, I will have in the numerator 2 sine 2x. The denominator I will have 2x multiplied by cosine 2x. If we multiply this by cosine square, up and down, we will cancel this one, and this power will cancel with this down. I will have only cosine 2x, and this will cancel the 1 in the numerator. Plus 2x squared multiplied by sine 2x. can see this is over 0. Which means now I will differentiate this because this will be easier to differentiate. Applying the Laminar rule. So this is equal to the limit of. For the numerator, I will have 4 cosine x. For the denominator, we can apply the product rule. It will be 2 multiplied by cosine 2x minus 4x multiplied by sine 2x plus, this is the derivative of the first part only. Second part, x squared or 2x squared, I will have 4x multiplied by sine 2x plus 4x squared multiplied by cosine. Plus 4x squared multiplied by cosine 2x. As x goes to 0, replace x by 0. This one will be 0. This is 0 and this is 0. And cosine of 0 is equal to 1 and this is equal to 1. So I will have 4 over 2. So the limit for this function is equal to 2. So the answer for this question is x or the limit equal to 2. So this is the idea. Sometimes I need to simplify the function, or I can directly differentiate the function, but it will be a little bit complicated in that form because I have to apply many product rules. It can be done, or I can simplify it and make it easier to differentiate. Number 3, example number 3. Let's find the limit of the function x minus pi multiplied by cotangent, where x goes to pi. When you replace x by pi, you will have 0 multiplied by infinity. It is 0 multiplied by infinity, which is indeterminate form. Now to find the limit for this using the Laminar rule, we have to write it as numerator divided by denominator. But I have multiplication. So I need this rule. If you have a multiplied by b, this can be written as b divided by 1 over a. A multiplied by b can be written as b divided by 1 over a, or a divided by 1 over b. This is one way. Another way, the cotangent function itself, in some cases like what we have here. Cotangent is cosine over sine. So to write it as fractional function, I will write it as fraction, limit of x minus pi multiplied by cotangent is cosine of x divided by sine of x. X goes to pi is equal to the limit of x minus pi multiplied by sine of x divided by sine. Either I will write it in this way, or I will apply this rule. I will keep that rule for different example. So cotangent is equal to cosine over sine. Now if we replace x by pi, I will have 0 over 0, which satisfies the condition of the Laminar rule. So we can differentiate. For the numerator, we will apply the product rule. That will be 1 multiplied by cosine x minus pi multiplied by sine over derivative of sine is equal to sine x as x goes to pi. Replace x by, this will be minus 1, this will be 0, and down will be minus 1, so it is minus 1 divided by minus 1. So the limit is equal to 1. Limit for this problem is equal to 1. One more example. Number 4. Find the limit of sine x multiplied by ln x where x goes to 0 plus. This is 0 multiplied by infinity. 0 divided by infinity. Now I need to write it as fractional function. So I'm going to use that rule. A multiplied by b equal to b divided by 1 over a. We can do it in this form. So this function can be written limit of, I will keep ln x up, because the derivative of ln of x is 1 over x, and 1 over sine x down as x goes to 0 plus. This is now of the form infinity over infinity, which means that we can apply the Laminar rule. Okay, this is or minus infinity over infinity, which is one of the indeterminate forms. So by the Laminar rule, we differentiate derivative of ln of x is 1 over x. 1 over sine equal to cosecant x. The derivative of cosecant x is minus cotangent x multiplied by cosecant x as x goes to 0 or 0 plus. So I will have 1 over infinity divided by cosecant of 0 is equal to infinity times infinity. So this is infinity over infinity. Again, I have infinity over infinity. So we can differentiate, or we can simplify first. Let's simplify the function. Then try to differentiate. We know that cotangent multiplied by cosecant x is equal to cosine x over sine multiplied by cosecant is 1 over sine. It is cosine divided by sine squared. And I have minus. So this one will be written as limit. The limit I write it up, so I will just write it in 2 steps. 1 over x minus cosine over sine squared. Which is equal to the limit can be written as minus sine square up over x multiplied by cosine x goes to 0 plus. Now we can differentiate this using or find the limit using the Laminar rule. Equal to the limit of minus 2 sine x multiplied by cosine x. This is by the chain rule. For the denominator, we apply the product rule. It is 1 multiplied by cosine x plus, or to be minus, because the derivative of cosine is minus sine, minus x times sine. X goes to 0 plus. Replace x by 0, will be 0 over 1, because this one is 0, this one is 0, and cosine of 0 is equal to 1. So I'll have 0 over 1, or it is only 0. So the limit for this function is equal to 0. We apply the Laminar rule. We wrote the function as a rational function, numerator divided by denominator. Then we apply the Laminar rule to find the limit, and we got 0.